All right, so we're going to continue into word problems. We're going to kind of tackle some harder word problems now. Um, we just looked at the chemical equation balancing problem in the last video, and so now we're continuing along. So this problem has a lot more information in it. Let's try to sort it all out. We have a bag of American Eagle coins, which some of them are half ounce, quarter ounce, and 1/10 ounce. These are gold coins. And then we say that the half ounce coins are valued at $285, the quarter ounce coins at $150 each, and the 1/10 ounce at $70 each. The bag contains a total of 58 coins with a total weight of 17 ounces and a total value of $10,000, $10,065. Here's our question. How many gold coins of each type are there? So, how many gold coins of each type? Each type being half ounce, quarter ounce, and 1/10 ounce. So we have, this is our first three variable situation. Let's write down our variables. Let's let X be half ounce, well, number of half ounce coins. And then Y will be number of quarter ounce coins. And Z is the number of 1/10 ounce. Okay. And then we want to look for our equations. And again, to write equations, we look for numbers that occur in the problem, and that we could write an equation based around those numbers. So specifically, I see. Note, oh, by the way, also, since we have three equations, or three variables, we're going to need three equations here. Three equations for three variables, okay? All right, so numbers that I see a total of 58 coins, I see a total weight of 17 ounces, and I see a total value. So I think this one's pretty easy because we're going to write a total number equation. We're going to write a total weight equation, and we're going to write a total value equation, which are relatively straightforward. I mean, not to say that there's nothing to do here, but it could be worse. Okay, so our total number of coins is 58. And this is simply the sum of X, Y, and Z, because X is the number of coins of half ounce, and similarly for Y and Z, it's just the number of. So X plus Y plus Z is equal to 58. Okay, so that's our total number. Now our total weight, it's going to use the same idea of weight per coin times the number of coins of each kind. So for the half ounce coins, for example, the weight is a half ounce, and then there are X of them, so that would be 1/2 times X, and that's going to be the number of ounces contributed by the half ounce coins. Sorry, that's supposed to be a plus. The quarter ounce coins would contribute 1/4 times Y, and the 1/10 ounce coins would be 1/10 times Z, and together they add up to be 17. Finally, we have a value equation, which is going to be the same as our other value equations and other problems, which is value per item times number of items contributed. The total value is 10,065. And see, we don't need to multiply that by anything, because that is the total value. We don't multiply that by 58 or anything like that. $10,000 is $65. And then for the half ounce coins, they are worth $285 each, so that's 285 times X. Quarter ounce coins are 150 each. And the 1/10 ounce coins are 70 each. And there you go. A 3x3 system awaits us. So that is a 3 linear equations and 3 unknowns. I was careful when I was putting this together to put everything in the nice normal form, so I don't have to do any fancy footwork. Let me just skip to my matrix system. So here is the matrix. It's okay, so it's a little bit different order. This one puts the total amount and then the total value and then the total weight. So this would be amount, value, weight. So I apologize for that, because that's actually going to mean that my y, the way I define y to be the no, never mind, sorry, I'm confusing myself. Everything's fine. It's just the order of these quantities is a little different, but it's still going to come out XYZ is the number of a half ounce, Y is the number of quarter ounce, Z is the number of 10th ounce. Okay, so put your matrices in. It's a 3x3 and a 3x1. We would need to do the inverse of this, so it's going to be the inverse of this matrix times this matrix. And I will not do that on camera. I'm going to let y'all do that on your own, but here are detailed instructions as far as how to type it all in. And you should get this as your answer. Okay. 19 half ounce, 24 quarter ounce, 15 10th ounce. All right, let's move on. So this is this particular problem, these types of problems, these are confusing to people because they are mixture of mixture problems. Mixture of mixture problems. And you do have problems like this in the homework, so watch, make sure you watch this example to help you with the homework. Okay? So here we go. Commercial customer orders 50 gallons of a paint that consists of 35% red, 40% green, and 25% blue. So the customer is ordering 50 gallons of a mixture of a paint of 3 mixtures. The store is going to prepare this order by mixing three other paint mixtures that they have plenty of. So for some reason, I have a reddish paint that's a mixture of red, green, and blue. Then I have a greenish paint that's a mixture of red, green, and blue. And then I have a bluish paint that's also a mixture of red, green, and blue in these various proportions. So I'm mixing these mixed up paints together to get the desired product. All right, but nevertheless, let's still follow our same rules. What are the unknowns? And okay, this is where it's really, really important to answer these questions, because you will screw up if you're not careful about this. So the unknowns, how many gallons of each? What are each? Each is each is these 3 things: the reddish, the greenish, and the bluish. So let's let R be number of gallons of reddish, not red, but reddish. And then G, number of gallons of greenish. And B, number of gallons, blah, 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 of bluish, okay? So RGB. And we know, now we look at the other numbers. We have this, the easiest one is right here. We're going to get 50 gallons total, so we're going to have a total amount. So the easiest equation I can write is X plus Y plus Z equals 50. Total amount of reddish plus greenish plus bluish has got to equal 50 gallons. So I've got one equation. Now I need 2 more. And if you think back to like your mixture problems, I'm sorry, what is it that we're trying to equate? Like with the methanol problem that we did several videos ago, remember that we wrote a pure methanol equation? So what I'm going to do is I'm going to write a pure red equation, a pure green equation, and a pure blue equation. So in other words, I'm going to say how much pure red is contributed by the reddish, the greenish, and the bluish, and that's got to add together to be the amount of pure red in my final thing, which is 35% of 50. Okay, so let me do that. I'm going to copy this down again. It's too big. Let's see, can I just move it out of the way? Just to give you an idea, just so we keep all the information on the same page here. So a pure red equation. Okay, so we're going to have the reddish plus the greenish plus the bluish equals 0.35 times 50. Okay, and then from the reddish, how much red is in the reddish? Well, there is 1/2 red. So that is 1/2. Remember, this was R. So this would be 1/2 R. And then from the greenish paint, it is 1/6 red. So that's going to be 1/6 G. And then from the bluish, it is 1/5 red. So that's going to be 1/5 B equals 0.35 times 50. Okay, so that's equation 2. So now I have 2 equations. I need one more. And this is kind of an interesting scenario because this is a case where I actually could write, because I have 3 unknowns, so I need 3 equations, but I could actually write 2 more equations if I wanted to. I could write a pure green equation, or I could write a pure blue equation. I don't need both of them though, because I already had this equation. That's 1, and then 2, and so I have more information than I actually need. And so you actually don't want to write all 4 equations. If you have 4 equations and 3 variables, it's going to mess you up. So just pick one of these 2. It doesn't matter which one, green or blue, I don't care. I'm going to pick green because it's the first in the list, and I'm going to write a green equation, and I'll even write it in green. So my green equation, it's going to be 40% green paint of 50 gallons, so it's going to be 0.4 times 50, and then over here it's going to be 1/4 R, because right there, and then from the greenish it's 2/3 green, so that's plus 2/3 of green, and then finally from the bluish paint is 1/5 green, and so that's 1/5 B. Okay, and that would be my 3rd equation. Okay, so this is equation 2. This is equation 3. And this is equation 1. And like I said, you could have used blue. It doesn't matter. In fact, out of these 4 equations, you can pick any 3 of them and you will get the correct answer. But so now we need to kind of compile all this stuff together. I'm going to skip through through this exposition, and I'm just going to go straight to the matrix system. Here's the matrix system put together, or the 3 linear equations. And from that, we can pull this matrix out and use our standard 3x3 and 3x1 matrix to solve this. I'm running short on time here, so I'm just going to try to wrap this up. Do your inverse matrix multiplication, and here is your answer. Okay, I am out of time with this video, so I have to stop it. But that's basically the solution, okay, to these mixture problems. Okay, thank you.